Okay, I think we're on. Hi, everyone. Hope that you're all doing well.
Okay,
so
I
my
think
name's
we're
Tom.
on.
I'm here with Owen as well. We both
hi,
work at Canva, and we are doing a guest speaking for the next hour. So strap in. Hopefully, it'll be a lot of fun. Okay, so a little bit of introduction to Canva. If you've not heard of Canva before, we are a company that develops an online product which empowers the world to design. So it's a tool that allows you to create pretty much anything that you can think of, from social media posts to letters to business cards to videos and so on. And our mission is to empower everyone to design. So we say this in the long form as empowering everyone to design anything with every ingredient in every language on every device with the best team in the world. And we're doing pretty good so far in terms of empowering everyone. We've got over 50 million monthly active users the last time we've counted. So 50 million people, or 55 million people actually, who log into Canva every single month
in the world.
There we go. And this is just a bit of stuff about our values. So employees at Canva generally try to align with these, being a force for good, pursuing excellence, making complex things simple, empowering others, setting crazy big goals and making them happen, and being a good human. So we've got two speakers today. First of all, I'll pass over to Owen to introduce himself. Owen.
Hi there. So I'm a group engineering lead here in Canva. The group I run is called Ingredients, which is basically that brings all of the content you see, videos, images, photos, all that sort of stuff into Canva for you to use in your designs. So next slide, Tom, and I'll say a little bit about where I come from. You might guess from my accent, I'm not Australian. I was born, raised in Ireland. I went to university in Trinity, where I did a PhD because they have the best gowns, as you can see. Then that took me for a career in IBM research for a few years, working on some very low-level hardware stuff, which was really cool, really good fun. Eventually I moved to the cloud and to Sydney, and 5 years ago started in Canva. So it's been a pretty cool journey ever since.
Awesome. And my name is Tom. I am a front-end engineer, also working in ingredients at Canva. So I, as you can guess by my accent, am from Australia. I initially started off, I was born in Newcastle. I did a year of film and sort of creative studies before moving over to UNSW and doing a Bachelor of Computer Science. In the later half of that, I was a full-time intern at IBM, and that became a graduate position once I graduated. And I was at IBM for 3.5 years. And then in August of 2019, joined Canva. I've been here ever since. So you've got two former IBMers here today. Okay. So we've got two talks today. I'll be giving one, and then Owen will be giving another. So my talk today is on front end at Canva. It's a bit of an overview of what it takes to design a product feature from the perspective of a front end engineer. I won't be going too much into detail on the actual engineering side of things, but I will be talking a lot about just the considerations that we have to make and how we go about planning out these features. I'll be talking a little bit about engineering at Canva, and then talking about building a product feature. And then, time permitting, I have a little bit of a soapbox at the end of things that I wish that I knew when I was at uni. So I'll finish off with that. Okay. So Canva has a massive engineering team. I think it's over 800 at last count. And we work across pretty much everywhere. We have engineers in front end, back end, infrastructure, data, machine learning, graphics, and so on. Pretty much any function of the business that you can name, there's a high chance there'll be an engineer embedded somewhere in there. But over 35% of the company, of our engineering specialty, is front-ended. So we have a lot of engineers, and often the question is asked, why do we have so many engineers? And I think the clue is in our mission statement, right? If we say empower everyone to design anything with any ingredient in every language on any device, there's a lot of everys and any's in that. And the more that you add them up, the more you start to understand exactly why we need so many engineers to accomplish that. And having that amount of engineers creates a lot of unique challenges for us. So if you've ever worked on like a smaller project or a side project before, you'll know that there are certain things that are pretty easy and some things that are hard. But when you get to a level of having over 800 engineers, you tend to find in some areas that this flips a bit. Some things become a lot easier than you would expect, and other things become a lot more difficult. And our ability to weather the changes that this creates and scale our organization up is really a measure of how successful we are as a company. But we have a lot of engineers, but 35% of them are front-enders. Why so many? Well, that's what I'm going to try and answer today. So I'll be looking at how we build a front-end feature. We're taking you a little bit through all of these stages, but I really want to focus in detail around two in particular. That is strategy and build. So I'll be talking a little bit about how we decide what to build and then talk about building it. And then at the end, there'll be time for a bit of Q&A, and I'll go through the YouTube chat then. So just a note before I start, Canva is a pretty typical agile company. We try to build things iteratively rather than doing things like this. I'm sure, being at uni, you've seen this graph before, but, skateboard is better than just an empty set of wheels, etc. Okay, so a little bit of background setting on strategy first. Time is one of the most valuable resources that a software engineer can have. So we're not civil engineers, right? And we're not electrical engineers. So we're not weighed down by resource limits in terms of the amount of concrete that we can have. We don't have a sort of voltage limit on what we can do. Really, so long as we're inside the world of software, it's possible for us to do pretty much anything, given enough time. So given enough time, we could solve most of the problems that we set our minds to. The main limitation that we have is that we don't have enough time to do everything that we want to do. And the context here is important. So at university, I can remember, getting programming assignments and the solution would be given to me essentially, or at least the problem would be given to me. And I'd have a limited time span, maybe like 4 or 5 weeks to do some big programming assignment. And then, being a pretty typical uni student, I would start the night before, get it done by midnight or whatever. But in your career and at Canva, things are a little different. Often we're tackling problems where we don't really know what the problem is, and we don't therefore know what solution we need to build. So I look at strategy more as the art of defining exactly what the problem is that we're trying to solve and the solution. And it's something that you don't often get taught particularly much at uni, I think, because it's an area that can be quite creative. So it takes a lot of experience as an engineer to be confident about what you want to build. And it can be hard even identifying what problem you're trying to solve. So these decisions are often handled at a more senior level, usually by a product manager or a designer, or maybe just a more experienced engineer than you would see a junior or mid-tier do. So as a junior or a mid-tier engineer, your role in strategy is really to answer questions that are posed to you and to assess the feasibility of solutions. So if a designer were to come to you, for example, with a certain interface that didn't look like it could be implemented in the browser, then it would be your responsibility to inform them as early as possible so that they can adjust their strategy. You also have a role in setting the technical direction of the code that you're working on. So let's assume that you're a junior or a mid-level engineer. The strategy has been decided for you by a product manager. And at this point, you know sort of what you want to achieve, but you don't know what it's going to look like. So the next step is usually the design step. A designer will start working on how this feature should look, either through an app or through a website or similar. It doesn't happen for every feature that you'll encounter, but as a front-end engineer, you'll have a pretty close relationship with the designer that you work with. And your main role there will be to still assess the feasibility of what they're doing. So as a front ender, we have input into designs. We have input into how they should look. But of course, the designer has the final say usually on how an interface should appear. Although it is becoming increasingly common, and you might see this, that some engineers work across both design and development. So there are a few advantages to that. Designers will typically know how to make something look really great and be simple and easy to interact with. But they may not know the ins and outs of the browser engine or, what's possible in mobile, for example. So it can be useful to have that relationship or just be one person doing both things. So generally, as an engineer, throughout strategy and design, you won't find yourself thinking much about the system. But at Canva, after that, you've got to start looking at the system architecture for the feature that you're working on. At Canva, usually, if you're doing a major change to some form of system, you'll need to write a proposal. This is common across most large companies. You see, the proposal is there in order to communicate to other engineers in your team or elsewhere exactly what you're looking to change. And it's also a guardrail because it allows you to propose a design that can be peer reviewed by other people before actually implementing it. Because the worst thing that you can do is you can design and implement a system in which there's a significant flaw, but by the time you've designed it, you haven't realized that because you didn't go through a process of actually designing the architecture, and then you have maybe weeks or months to try and fix this issue. So in a typical proposal, you're going to get peppered with questions. You might have some sort of design in mind, right? You might say, I've got this page and I want to implement a button that downloads, does some form of machine learning, for example. Let's say it calls out to a machine learning model. And some of the questions that you might get would be like, well, what API are you using to call this machine learning model? How will you account for mobile? How do you handle errors and edge cases? What if the machine learning model fails? Or what if it returns an output that the user doesn't think is correct? Or how much effort would it be? Do we need to train a new model? Can we get one off the shelf? And how do we validate that the feature is actually successful? These are all questions that you're going to be asked usually before you start coding. Although depending on the size of your company, the urgency of the feature or the relative impact, sometimes the system architecture isn't quite as important, but it's still worth thinking about. So you've got your mock-ups ready, your delivery plan's in place, your system architecture is designed, and now you need to build. Before, I remember growing up, I was like 8, maybe in the early noughties, and it was super easy to write a web page. You would just write like an HTML file and a CSS file and some JavaScript, and it'd be accessed over a computer, and it'd probably be written in English. These days, not so much. It's a lot more complicated. There are a lot of considerations to make if you truly want to make your page accessible for everyone. And as a front-end engineer, I think the primary responsibility that you have is to ensure that your feature or your code can be accessed by everyone in a way that feels natural and not complicated. So I'll start off with something simple. Browser support. Do people still use Internet Explorer? Sadly, they do. So 1.5% of people, not that many anymore, but Internet Explorer is one thing. Safari isn't great either. So Safari and Internet Explorer are browsers that at least 10% of people use, but they display or do inconsistent things to other browsers. If you were to call, say, an API against the browser to download a file, then Safari and Internet Explorer might handle that differently to other browsers. So most browsers are powered by an engine called WebKit. The WebKit browser engine powers Chrome, Safari, Edge. I think it powers Opera, maybe Brave. I know it powers Brave, I think. Powers a lot, pretty much most things except Firefox these days. So we could write our features to support, just the latest version of WebKit, but at least 10% of users would have a terrible time. And just supporting standard WebKit isn't enough because Safari doesn't implement things consistently with how the WebKit standard, says that they should be supported. But also, a lot of users might be using an older version of the browser and so on. So this can affect things in multiple ways. I can give you an example. If I were to implement a drag and drop system, for example, and I would have a series of buttons with images and I wanted to drag and drop them. Well, the behavior of drag and drop is different on Firefox and on Chrome. So that's one. If we were to take a step out, we can't really assume anymore that our web pages will be used on the desktop, for example. So over 61% of people now use the web from a mobile or tablet device. And this is an interesting one because I think most people would design for laptop first. And maybe that's a function of developers, having crazy expensive laptops or whatever. But it's not the truth. Users don't only use pages on mobile anymore, but they actually expect that they'll want their page to integrate well with mobile and the native features that mobile provides. And supporting mobile means rethinking a lot of the basic assumptions that you might make about a web page. So, example, this slide is a good one. This slide has a column on the left-hand side. It's a sidebar, and it actually sort of looks like a web page. On a standard web page in desktop, you would see like some navigation items in the sidebar here. But on a mobile device, well, a mobile device is mostly portrait-oriented, right? So you need to adjust your layout to fit. Or I might desire a feature which requires me to long click on an image, for example. So I might click and hold it down for 3 seconds and something would happen to an image, which would work great on desktop, but on mobile, long clicking on an image or long pressing on an image is equivalent to a right click. So that doesn't work. CSS, when you're coding things in CSS as well, you might default to hard coding things like padding and margins using pixel values. It's not particularly helpful to be doing that anymore. If you consider something like a retina display, which will push a larger amount of pixels into a smaller space, 8 pixels can mean a very different thing depending on what device you're on. In a large organization as well, Android, iOS, and web is 3 different code bases technically. Android would be Java or Kotlin, iOS would be Swift, and web would be JavaScript. That's pretty prohibitively expensive, and it's hard to ensure that you can deliver a solution across all technologies equally. So there are some technologies that help you, like React Native, Apache, Cordova, Flutter, which would allow you to develop on one code base. So that's something you'll often see, particularly if you've used an app like maybe Airbnb, I think used to use React Native, so they could develop on the same code base and deploy to Android and iOS at the same time. But it's not just about making your page accessible to different devices and different browsers. It's also about making your page accessible to different cultures and different societies, and different internet connections. So not everyone, in the Western world, in Australia, we're pretty privileged here. In the US, it'll be the same. Everyone's probably got access to a pretty decent device. But the truth is that people access apps and pages from whatever device they can best afford. And for some, that's a MacBook Pro, but for others, it's an $100 smartphone. And we have a social responsibility, really, to ensure that our page can be accessed by everyone as easily as possible. So if you've developed a JavaScript application before, you would have seen a node modules folder. It is a massive folder the minute you pull in dependencies. And the sad truth of it is that when you do this, users will have to download most of it. And this means that pages can be over a megabyte. The problem with that is that if you have to download over a megabyte, you're probably not going to want to stay on the page. So there is a lot of data to show that the amount of time it takes to load a page can directly impact the amount of users using a site. Even at 5 seconds, you're losing over 40% of users. They'll just basically, bounce rate means they'll load the page and then they won't interact with it. They'll just leave immediately, clearly because the page hasn't loaded. So say we had a 1 megabyte JavaScript bundle, which was the button calling the machine learning model. And the button itself was pretty heavy, right? Out of the 1 meg of data that we have, 750 kilobytes is devoted to this button. A technique that we can use to optimize performance for most users is something called chunk splitting. So say we've got this 1 megabyte JavaScript bundle, we could split it into two. The first one is 250 kilobytes, and that's most of the core functionality that a web page would expect to be able to run. And the second one is the bundle to do this machine learning button, right? And maybe not everyone will use it, but when they do, they'll have to download the rest of the JavaScript bundle, which will ensure that performance is optimized for the people who don't use it. So that is one technique that we can use. It doesn't fix performance so much as amortizes the cost of performance for most users, but it is a good solution. I said before that in the noughties, you might have assumed that most pages would be written primarily in English, and that's just no longer the case anymore. Supporting every language and culture is pretty important to us at Canva. We believe that the platform should be available in every language. And we have dedicated engineers to work on this whole internationalization and localization team. Because it's not just about translating copy. If it was just about translating words, we could fire everything through Google Translate and hope for the best, but it's much more complicated than that. Let me give you an example. Most languages, English, for example, would be orientated so you read from left to right. But you would be aware that some languages read from right to left. So, I think, or if you've seen, like, I think manga in Japan, right, does that, where the comic strips are labeled from right to left as opposed to left to right. And some formal scripts also use up to down. So you might be able to solve that. You could translate every word, and then you could change the orientation of your layout. You could move it so that all of the text that was aligned to the left is aligned to the right in certain locales or browser sort of configurations. But it's not as simple as that, because truly localizing a product, making it supportive of different languages and cultures, means we need to ensure that the nuances of the culture and the language is respected. So an example would be certain languages have gendered terms, or formal and casual honorifics. And also colors in branding can also affect the way we're perceived. So there's no face cam on, but I am white, and I have ancestry from Britain, Ireland, England, and so on. So for people from where I come from, the color white, that's okay. It's a pretty innocent, it resembles purity and innocence and holiness, and is generally considered to be a pretty positive color. So say that I'm in Europe and I decide to start a company, maybe a medical company, and my logo is white, maybe a white stethoscope on a black background. And I try to market my company to somewhere in Asia, say China, for example. The meaning of the color white there is very different. It can symbolize death, or it's the color of bone. So you can see even basic assumptions that you make just turn out to be incorrect. And so the nuances of what you do become quite important. We have a responsibility to ensure that everywhere in the front end that you can access the page, through every device, browser, language, that it performs on low-powered devices. But there is another area, which is making sure that our platform works for disabled people. So people who might be vision impaired or motor impaired or are just hearing impaired need a way to be able to access our page. It's our responsibility to do that because we want to empower everyone to design, not just people who are able to use the page in the way that we see fit. I wanted to include a video of a screen reader here, but probably too long. Just suffice to say that your page or app should work with screen readers. Ensure your colors contrast as well, or at least offer a high contrast color theme so that people can, and ensure there are multiple ways to interact with the app. Mouse, keyboard shortcuts, using the screen reader, these are all good ways. Supporting all of them means that your app is as accessible as possible. An example is like this image here. I might put an alt tag on it. This allows screen readers to see that when an image shows up, they can actually read out the contents of the alt tag and ensure that the person who is not able to see the image still gets an adequate description of what the image is like. And yeah, the web WCAG, or the Web Consortium of Accessibility Guidelines, is the group responsible for this. I highly recommend looking up their documentation. They've got very, very good documentation on how to make things accessible, so I won't go into it in detail here. But if you're ever stuck for that, have a look. Okay. So we've built everything. All of our considerations to make our feature as accessible to everyone as possible have been taken into account. We can assume that our feature is good to go. How do we validate it? Testing. I'm not going to spend too much time on testing. I'm a big advocate for testing personally, but like it is single-handedly the best way to validate whether our feature works as intended, and it's pretty much a non-negotiable. Don't fudge on tests. The one thing I will say is that, you know, tests don't only improve the quality of your code base. If you're a person who's in a position where, you know, if your code goes down or there's an outage and you're being forced to fix it, then tests are going to save you a lot of time and probably give you your weekends back if you implement them right. If you're a student, you've probably seen this before. I would say that unit testing is pretty much required, at least in the majority of cases. Integration testing and end-to-end become more important the more used your page is, the more users it has, but definitely start there. The one thing I will say about testing as well is that they're really great at testing code correctness, but they're not so good at answering if users are actually going to like what you've built. Everything up until now has been speculative. So the strategy and the design, the system architecture, it's all supporting a theory that you don't actually know is true. And you also don't know if your feature is going to work if you throw over 100,000 users at it or more. So you need a way to be able to validate this. One approach you could take is something called feature flags. So this is a pattern in your code. It enables you to turn on or off a code path. And the code can exist on the page just fine. Users would download it, but it's not exactly active. It's not being used right up until the point that you decide to enable it in code. And this allows you to do something really interesting. What it enables you to do is roll out a feature to a certain percentage of users if you have the right system in place. So you could roll out a certain feature to 1% of users and then capture maybe 50,000 users in that. And you'll start to see bug reports fly in and errors, and you can fix them up, or you can get feedback from your users more directly, and you can go back to the drawing board if something's wrong. You can iterate, you can improve your product again, and you can release to more people, and so on until it is released to 100% of people. So everything's released. Great. It's time to do it again. But when you write a uni project or a side project, or you're doing anything like that, it's pretty common to throw code away. But in a large code base, you can't just write code and forget about it. Code itself it's a thing. It has like an intrinsic cost to it of maintenance. So code, you need to make sure that it keeps up to date with best practices across the code base, and it needs to keep in line with changing requirements, which means that you need to constantly maintain it. You could almost look at code as something that's living. And if you don't tend to it, it's like a plant, you know, if you don't tend to it and water it, it's just going to die eventually. And the form of death it takes is that it becomes impossible to maintain and no one understands what it does. So one way in a large organization that you might fix this, there are a few ways, but you might take on a system called code owners, where maybe a page or a module or a unit of code is assigned an owner, and that owner is responsible for overseeing that it is maintained over time. Cool. So that's the whole cycle. Once the cycle is complete, usually you start again. We were talking before about things being iterative, and that's really important. Usually these cycles don't take too long, maybe a month, maybe 2 months, or less ideally. The smaller you can make the smaller you can make the work that you do in order to validate the success of what you do, the better, you know, process that is. Like, if I can spend a week to validate that this feature is actually going to be valuable rather than 2 months, that's a win from our perspective. And often you'll find that a lot of features might be tried, but only a few will get through. So it's very best to fail fast and just learn from it. So I hope that gave you some insight into the product process at Canva from a front-ender's perspective. particularly focusing on access. You know, when we're talking about empowering everyone, I really wanted to focus on just emphasizing that that means there's a lot of considerations we have to make around people accessing our code. And yeah, so look, I am not sure if UQs has a front end course or not. I know that UNSW did not. So when I was there, I basically taught myself, and I found there was a lot of assumptions I've made and attitudes I'd had that proved not to be helpful when I joined Canva. And I think this probably applies to most large scale engineering organizations. Like you'd probably find the same thing at Google or Facebook or something like that. So I've just got 3 tips. The first one is to learn the basics, which sounds really obvious. But one of the things I often find with a lot of intern and graduate engineers is they'll spend a lot of time learning React. And that's really valuable. React is a really great library. We use it at Canva, and it is, you know, our bread and butter. But React is, at the end of the day, a JavaScript library, and it will serve you well right up until the point that you encounter an error that you can't solve. And if you don't have the JavaScript, HTML, and CSS fundamentals there, you're not going to be able to get out of that hole. So I recommend really spending time to learn the basics of JavaScript, HTML, and CSS, and don't graduate beyond that until you're confident. Because we do see that can help. That's a really great opportunity to set yourself apart, and something that I wish that I knew, because I jumped straight into learning like Angular 1 at the time. The second tip is to always be pragmatic. So quality in your code base is really important. Try to write simple and clean code wherever possible. But if you're forced into a position between waiting a few months to deliver the highest quality solution or shipping value right now, often you'll find it's more prudent to ship the value straight away, because you don't know if the feature is actually going to be valuable until it's shipped. You always have the opportunity to come back later and clean up after yourself, ideally, or iterate on the feature as you see fit. But the important thing is just make considered decisions about your code. And lastly, be a good person. You can be the best programmer in the world, but if you're sort of a dick, then it's not going to matter too much. I find that communication and leadership are probably the most fundamental skills an engineer can develop. They're incredibly important. Being an approachable person who is able to help people up their skills as well is one of the most valuable things that you can be. And I would say that these things matter more than your code in pretty much 100% of situations. Cool. Thank you. Okay, I'm going to jump onto YouTube. I've got a few questions. A Canva team's responsible. Oh, Owen, thank you. Cool. Okay, so Owen's answered the questions. Owen, I guess I'll do the same for you if you want to start your presentation now. Yeah?
Yeah, drop yours off and I'll...
Great. Okay.
Hang on a sec. Sure it's working. Okay, great. So I'm going to talk about building for scale. So Tom is a front-end engineer. I'm very much a back-end engineer. So we have complementary but not very overlapping skill sets of views. So I'm going to do this by talking about how we follow it. And this is a little bit more rather less. So we're going to, well, rewind for a sec. if you want to build for scale, scale is really just a problem. It's just a particular problem. In Canva, we experience scale at a fairly high level, but it's just an engineering problem to solve. So like any engineering problem, the first thing you actually have to do is define what that problem is. Because you could jump in and go, hey, I've got an idea, I'm going to do it. But you don't know that it's going to solve the problems that your users are experiencing and solve the core issue that you need to solve. So then having defined the problem, now you can figure out what are your solutions, what are the options, and choose the best option there. So effectively define the fully solved state. And when I say fully solved state, there are times when you want to just patch it and fix it and just do this, just get it back up and running again. But most of the time, what you actually want to say is, I want this, I want to understand where do we want to be in 3 years, assuming that we continue to scale and all those things. And that's what a complete solution looks like. And then having figured out that complete solution, we obviously can't spend 3 years building without shipping. So we need to break it down, set milestones so that we can ship value to our users as early as possible, because we're always wrong. Like, this is the fact of life. You think you're right, but you're not. And it's only when the users get your hands on the feature that you actually realize, hang on, I need to pivot a little bit and do things a little differently. So I'm actually going to talk about a specific problem that we have, which is not something you'll have heard so much about. We have a library of content in Canva. And that library of content has always been part of Canva. It's a fundamentally important part of Canva for our users. You can come to Canva with no images, whatever, search for, you want to do a flyer for your local dentist, search for some photos of a dentist. Perfectly, we've got some, drop them into your design and create an awesome design. So I want to talk a little bit about that library, how it's always been part of Canva and how we've had to deal with it scaling dramatically over the years to take account of our scaling user base. So first up, let's rewind to 2013. We'll find our DeLorean, and hopefully it's capable of 88 miles an hour. And Canva has an awesome image library, which we added right from the start to help users create the perfect design. This has got hundreds of thousands of photos and graphics, mostly photos, and they're mostly sourced from stock image libraries. Now, these 3 images are examples of some of our oldest photos. They're pretty good, very stocky in style, which is a phrase we have for things that come from stock image libraries, but gives you an idea of what we're talking about. And it's been great. The thing is, we had to add a review system because not everything that the stock libraries give us is something we want in Canva. There's a few different things that you need to check. You're checking for quality, you're checking that the compatibility is there with Canva. And so we built a review system to do this using humans. They look at the photo, make a decision, accept it, reject it, and they could choose a multiple rejection reasons. So our contributors knew what was wrong, and they could check and fix metadata. And it worked for the 2013 workload. So we're talking sort of hundreds of thousands, maybe like 100,000 images a year at most that we'd add. And even that would be a big stretch. But let's fast forward 5 years. Canva's been doing pretty well. But the problem is the library's now at tens of millions of images, not hundreds of thousands. And the old review tool, it just hasn't been able to keep up. It's not able to process the volumes that we needed to process. But our library is still absolutely fundamental to the Canva experience and how users experience and use Canva. So we need to fix this. This is something we need to rebuild. We're bringing to the modern era and to handle our current scale. So that's great. We kind of roughly know what we want. But let's just say, why are we doing a review? Like, what does it actually mean? What are the actual problems? Because if we don't dig into the actual problems, then we're not going to know what we're trying to solve. So we know we need to review millions of items a month. That's kind of probably we want to be able to review millions of items a month, right? So if we're talking about tens of millions, we get a certain amount of churn, you're going to need a certain amount of new stuff coming in every year, and you need to stay ahead of trends and so on. So you're looking at reviewing a lot of stuff. And what do our users want from this process of content review? I mean, in effect, what they want the Canva library to be a safe place. So they don't want it needs to be safe for a work environment. No violence, no racism, no not safe for work content. Quality needs to be good. It doesn't mean that every single image has to be amazing, but it generally has to be good. We don't want screens of really not very good stuff. That's not what people are in Canva for. And they want good search results. They want to find, when they type in a search term, they want to actually get that back. And what that means really is accurate metadata. And these are all things that we need to use review to do. We can't just trust our contributors to do it, because we know from experience they won't. And that's the way it is. So what's not safe for work? I mean, obviously I can't show you the photos. This is actually the thing that we show when you're not allowed to see an image. It's obvious stuff, right? No nudity, suggested content, violence, gore. We have pretty high standards on stock industry at large, so we actually need this. This is quite important. Another issue with safety, which you might not think about, is brands. So brands are things like, you couldn't necessarily use the photo of the runners in an ad for your gym on Facebook, because that may imply some sort of endorsement by the brand owner when it wasn't there. So there's a kind of licensing issue there that we need to avoid. So we want all photos, we want all imagery in Canva to be usable, no matter the destination of the exported design. Similarly, editorial imagery, you may not have heard of this. This is the kind of stuff that newspapers use about current events. And there's specific exemptions for them to use those images without getting the agreement of the person in the image. But that doesn't apply if you're making a Facebook post on your personal account. So there's kind of these safety issues for our users, but they want to be safe from any legal snafus. So we need to protect them. Racism, hate speech, this is something that comes up. We don't want anything glorifying anything like this. It just doesn't match any of our values in any way. But there's some interesting quirks. So something like a QAnon symbol 5 years ago, nobody would have really known what it was, and it was fine. Then all of a sudden, about a year ago, it was a big issue. Pictures of the Ku Klux Klan, a pretty hateful, horrendous organization. But there are certain things, this is one, it's a historical photo. So it doesn't glorify the organization, but is useful in an educational context. So we do have a limited amount of this stuff. And this is a very tricky judgment to get right, very, very difficult, and requires a sort of human input to do it properly. So for schools, another thing, we want Canva to be usable to anyone. So this photo is pretty terrible, but it might be fine in a, well, terrible, it's okay. It might be fine in certain circumstances, but not in a classroom. So these are all things that we need our review process to give our users in terms of safety. Another thing is quality. There's technical issues. We don't like text in our photos because we'd say, well, add it with Canva, then it works in any language. And we just don't want bad quality stuff. And then there's just this general problem of stuff that's not very good. The guy in a makeup salon, I'm not really sure about that one. And I would really worry about the handyman holding an angle grinder like that. I don't think it's going very well for him. So, these are all things we don't want too much of this stuff. A bit is okay in specific niches, but we don't want pages and pages. Finally, metadata. This is something that's quite different. And this is about understanding that the keywords you add should be relevant. So if you look at this, this is actually an example of something called keyword stuffing, where they've added a whole load of unrelated keywords in the attempt, hoping that their image will show up in search and get used. My personal favorite one here is holiday and summer, travel, vacations. There's nothing about this image that implies summertime or vacation or anything. It's credit cards in someone's pocket. So that's the thing that we need to review, is to strip them off and discourage. So what are the insights? Library is critical to Canva. It's really, really important to get right. If we get it wrong, everyone complains. If we get it right, Canva does well. The requirements are actually very complex. This isn't just a simple thing. Trying to judge which Ku Klux Klan picture is okay and isn't, that's something we need human involvement in. But there are there are times when it's simple, there are times when it's complex. And there's a lot of gray areas here, a lot of areas where it's, you need to use your judgment. We also have very specific requirements in Canva. They're specific to Canva. They're not global. They're not true for everyone. We have high standards. So to some extent, the key insight is we will need humans in this process to get a high quality output, but we will also need machines to help them, because we can't, at some point of scale, you end up deploying the entire world. So we need to take account of both. So what's the solved state look like? In this case, I should warn you, my presentational style is to stick random stock images into my presentation. So that's what you're seeing here. The library is safe according to those things that I've talked about. The quality is good. It's not pages of terrible stuff. It's good. Metadata is accurate. So we're getting accurate search, giving back users what they want. So sounds simple, right? 3-step plan, build a review system, review everything, make our users happy. But it's not simple at scale, because trying to review 100 million images or whatever the volume is at scale, it is very difficult to do that consistently and do that well. So we need to really get into the weeds here and think carefully about how we're going to build this and ways to be clever and do things well. So that's what I'm going to talk a little bit about right now. So remember that first review system. It was a simple thing. It was a single page. Afraid the screenshots are lost to the mists of time. Basically it asked our reviewers to do everything in one go. And what that meant was it was slow. And there's actually a really well-established way to solve this. That's a picture of a Model T Ford, which is one of the first things to be built using an assembly line process in the factories. And you'll see a picture of an unknown CPU, which is a well-known other example of this, which is you pipeline. Instead of doing everything in a single cycle, you pipeline it over multiple cycles. So this is a way of increasing throughput. And we're going to use that. We use that for review. And what we do is we break the problem down. So instead of having this one big chunk, we do some automated checks. Eliminate anything that can be reliably eliminated automatically. Just get rid of it, take it out of the pipeline. The next pipeline is humans looking at the pictures, making a quality check, saying yes or no. And it's very quick. They can say yes, no in a very small amount of time. And then following up with a metadata review. So then only the stuff that we want in the library gets its metadata reviewed, and that can happen a little bit later on. It's not as critical. But it's not enough on its own. Breaking the problem down like that, it will get us so far, but we aren't going to get into the tens, hundreds of millions unless we start employing a vast number of human reviewers. And the problem with humans is they're great, but they're not consistent one to the next. So our key here, the key for handling scale is to progressively add more and more automation, primarily through machine learning, but it's not the only avenue, but it's primarily machine learning. And this machine learning allows us to scale up, to make decisions more rapidly, assist the human reviewers to focus on where they can add value more and more. So the two ones we've done a lot of work on is not safe for work photo detection, using off-the-shelf models to flag potentially unsafe images that we then use a human reviewer to check. So these are things that would be fine, but not in a classroom, or sort of would be fine in certain circumstances, but certainly not in a regular workplace. So that's what we want to check. That's what we want to catch, and that's been really effective. But the false positive rate is high enough. The false positive rate is high enough that we can't just blanket use it. We still need a human checking what comes next. And then we have some super secret in-house models, which are specific to Canva. So these are things like figuring out whether an image is a photo or a graphic. This is something that's a particular pain point for us, but isn't usually an issue for other people. So we do some stuff as well. So yeah, so the first, but we'll get into a little bit into the milestones in a second. The manual quality review is, if you remember those review rules, you've got not safe for work, visible brands, editorial. So what we actually ask our users to do, we ask our human review team to do is if we look at about 40 images at once, and they make a call on each of those 40 images and then approve the batch. So it looks a bit like this. You'll see up here, there's a lady, low-cut dress. It's safe for work, but maybe not perfect for school. So it's been clicked on and marked as blue, which means not safe for school. You've got a couple of visible brands here, the Fender amplifier, and Little Lego Man. Shouldn't be in the library. And then we've also got 2 pictures of, I'm guessing is someone in current affairs. I haven't actually figured out who it is. But they would be editorial photos, so we can't have them in the library. It's unlikely that this person has signed a model release form for this photo. So we'll mark them out. And then down the bottom where you can't see, there's a button that you click approve, and then that will, or like it will like submit, and it will submit that, and then you get a whole new page. So that's cool. That works pretty well. It fits really well with what humans can do. So you're probably sitting here at this point thinking, you've been talking a lot about product. Where's the engineering? But at the end of the day, that's what engineering is. Engineering is taking our understanding of the world and using it to invent, design, and build things to solve problems and achieve practical goals. This is a quote I stole off the internet, but it's a pretty generic statement of what engineering is. And if you don't understand your problem, you can't engineer a solution. It's just, that's what we absolutely have. That's where I started. So having figured that out, what do the engineering requirements start to look like? Well, we need a system that can process millions of elements a month. That's 10K plus a day. And if we go with our 10X rule, one of the rules you tend to apply, particularly in Canva, is you say, well, okay, that's the solution for now. Will that work at 10X? If we're doing 10X the amount, will it work? Or what breaks? So we could be looking at, that's 10K per day right now, but we're looking at easily 100K a day. Can we support that? Can we support even 100 times, up to 1 million a day? And we want to support multiple reviewers working at the same time. So this is something that is really important, that we don't want people duplicating work. And we want to support a series of small, simple tasks. So array assembly line process. So what does our solution look like? Now, I'm not really going to get into the details, but it's a DB-backed workflow engine. It's a service that we've built ourselves within Canva. It's one of these fascinating things that, like, the ML gets all the glory, but actually it's the MySQL transactions that really do all the hard work. We could build all the machine learning models we like, but without a workflow engine to hang these things off, we would really be getting nowhere, because we couldn't have that interaction of humans and machine learning and other automation. And a key thing here is we had to, we had a good bit of fun writing SQL queries to do the transactional task assignment and completion. And it's kind of, there's 2 things going on here. One is that you need to be able to assign tasks to individual users, but you need to do them you have like a sliding window of tasks that we assign. And as they submit, we start popping more tasks into their assignment. So they've always got work to do and can keep going really, really quickly through that workload. And that's something where the front end, written by Tom, who you heard from earlier, has to work really closely with the back end. And there's a sort of a certain amount of the application logic that's distributed between the two in order to make this work really, really well. So it was pretty good fun to build. Yeah, so that's been up and running. But I guess the thing is, the milestone, I wanted to come back to that idea of milestone and what, like, delivering some value earlier. Right? And in that sense, like, the challenge here is we needed to build a workflow engine. So there was really no way out of that. That was just like, you have to take the hits, spend the time, and go and build that backend service. But we built it focused on 2 things. The first was getting graphics and photo review out early, and specifically focusing on quality check first. So we could get that up and running, get it into production, validate that we were right about our assumptions, and then move on to start looking at metadata. That's the second step. And then with that up and running, we were able to collect information about our reviewer behavior and start adding machine learning models and other automation to assist those human reviewers and improve speed. But part of, like, one of the things that makes us that's really important about defining the fully solved solution is we need to be able to support not just static photos that you've seen in my presentation here, but also other formats like video and audio. And that needs to be something that the system is extensible to do, because otherwise we didn't plan that up front and had just tried to solve the media review problem. We'd have found ourselves right back here rebuilding it again in order to support video review or audio review. So that's kind of our thing. But yeah, and it's been pretty successful. We've got the system up and running, and we're able to continue extending it for new content types, new automations, new actions. And it's been really adding a lot of value for our Canva users. And we're able to do that in an incremental way. If an issue comes up, a new requirement comes up, we can bring in a new review flow that then helps us meet that requirement within the library. So, any questions? Let's see anything in the chat. Sani, you're asking about the weirdest image. I don't see them. That's the funny thing. The reviewers see them, but I'm sure they've got some pretty weird stuff. Yeah, see anything else though. So I think that's us. Thanks everyone for your time.